Hi class, we continue with geometry. We are still discussing circle theorems. Yeah, so this is the 12th lesson for geometry, but this is the third class for circle theorems. Here is a theorem, and this is the problem that we can solve using this theorem. So you understand the theorem, then you'll be able to understand how we solve the problem. All right. So what we understand by theorem is that it's a principle we use to solve problems. Yeah. We have different cases in mathematics that we apply theorem, not only in geometry. Okay. So here is the statement, the principle, the rule, and here is how we can visualize it, how we can demonstrate it to understand what this write-up is all about. Okay. The opposite angles in a cyclic quadrilateral. You already know what an opposite is. Yeah, of course, you can see I stand here. The camera and myself, we are opposite to each other. All right. So the opposite angles in a cyclic quadrilateral. You can see W and X, they are opposites. Y and V, they are opposites. But the opposite angles are not always the case. The case here is they must be in a quadrilateral, and it has to be what? A cyclic quadrilateral. Quadrilateral is a four-sided shape. It's a four-sided figure. So you can see 1, 2, 3, 4. That makes it a quadrilateral. That is one. This quadrilateral is in a circle. That is the second point. But the final point is each of the angles of the quadrilateral contact what? The circle. So unlike this one here, for example, we can say we have this, we have a quadrilateral like this. Yeah, this one is a quadrilateral because it has 1, 2, 3, 4 angles. It has 1, 2, 3, 4 sides. This angle touches the circle here, the circumference. This one contact, this one gets contact, but this one does not contact. So this is not what we are talking about. What we are talking about here is one, the angles must be what? In a quadrilateral. Yes. The second point is the quadrilateral has to be in a circle. And the final point is each of the angles contact the circle. So this is what we mean by cyclic quadrilateral. So the opposite angles of a cyclic quadrilateral, in a cyclic quadrilateral, they always add up to 180 degrees. And you know that when angles up to 180 degrees, we can say they are supplementary angles. All right. So this tells us that this one is a quadrilateral. It is in a circle, and each of the angles contact the circumference here. So if x and w they are opposite, we can say w plus x is equal to 180 degrees. Yeah, this is opposite to this. We can say v plus y is equal to 180 degrees. Why these two statements equations are true? Because they are what? In a cyclic quadrilateral. I hope this one is clear. So now look at the problem we have to solve from what we've learned. Okay. So we want to find a and x here. We want to find a, we want to find x. So first of all, we have a quadrilateral. We have a four-sided figure. This shape has four sides. It has four angles. That is one, makes it a quadrilateral. The second point is this quadrilateral is in a circle. Yes, inside a circle. That is the second point. The third point is each of the angles of the quadrilateral contact the circle. So this one is a cyclic quadrilateral. So for a cyclic quadrilateral, the opposite angles are supplementary. The opposite angles sum to 180 degrees. So A and 181, A plus 81 is equal to 180 degrees. What is the reason? Because of cyclic quadrilateral. So now we can say A is equal to 180 minus 81. So what do we have? We have 99 degrees. So this is how we get that one. So how do we find x? How do we find x? So x and 2x, they are also what? Opposite angles of a cyclic quadrilateral. So we say x plus 2x is equal to 180 degrees. Yes, what is the reason? Because of cyclic quadrilateral. Yeah, so x plus 2x will give us what? Will give us 3x, which is 180 degrees. So we divide both sides by 3 to give us 60 degrees. So this is what we have for lesson 12. Thanks for watching. Don't forget to follow, like, share, and comment. See you in my next video.